Algebra I 8.5c. In the last couple videos, we solved motion problems for distance and rate. Now we're going to solve it for time. And we've talked about the problem-solving guidelines, that we need to understand the problem and know what it's asking us. And we need to develop and carry out a plan, how we're going to solve it. Then we need to find the answer and check it to make sure we did it correctly. And the strategies that we can use are, we can draw a diagram, find a pattern, make a table, write an equation, guess and check, work backwards, solve a simpler problem, or use a formula. We're going to use 4 of these strategies in this video. So remember, we can use multiple strategies for one problem, okay? You don't have to just use one strategy. So we've been talking about how D equals RT, and that's the formula for distance, rate, and time. And when we're solving for distance traveled, it's going to equal the rate of speed we're going multiplied by the amount of time it took us. Now, to solve for time, what we can do is take this formula, D equals RT, and we can divide each side of the formula by R. And that's going to create a zero pair right here and eliminate the R. Then, what we're left with is distance divided by rate equals time. So now we can solve for time. Remember that distance can be in any increment, miles, kilometers, yards, feet, inches, whatever, and rate can be in miles per hour, kilometers per hour, and that when we look at the rates and we compare it to the formula, R equals D over T, miles per hour, the word per kind of takes the place of that fraction bar, doesn't it? And time can be in any increment of time passing, okay? Hours, days, minutes. So 2 cars leave Mumbai, India, going in opposite directions. One car travels 60 kilometers an hour. The other car travels 30 kilometers an hour. So how many hours will it take for them to be 150 kilometers apart? So let's draw a diagram first. We've got a slow car and we've got this fast car. So this slow car is traveling 30 kilometers per hour, isn't it? And this fast car is traveling 60 kilometers per hour. Okay? And it's asking us how many hours. So it wants to know how much time is it going to take for them to be 150 kilometers apart. So when there's 150 kilometer space between them, how much time is going to pass before they get to that point? So the distance of the slow car plus the distance of the fast car is going to equal this 150 kilometer distance. So we're going to let T equal the time because both cars travel the same amount of time to get this 150 miles apart. They're going to travel at different speeds, but they're going to travel at the same amount of time. So let's make a table. So we have our slow car and our fast car, and our distance equals rate times time, multiplied by time here. And the slow car's distance is going to equal 30 kilometers per hour, so its rate is 30 multiplied by the time. The fast car's distance is going to be its rate of 60 kilometers per hour multiplied by however much time it is. But together, it's going to be 150. So we can actually write an equation of 30t plus 60t equals 150. The distance of the slow car plus the distance of the fast car is going to equal that 150 kilometers. See? So we actually have this one equation, don't we? So we can solve this equation for t, time. 30t plus 60t, we combine like terms and we have 90t. Now all we need to do is divide both sides by the 90, and this creates a identity property, invisible 1, doesn't it? Because 90 over 90 is 1, so we have 1t. When we simplify 15 over 90, how many times can 90 fit into 150? It comes out as a fraction of 5 over 3, see? And you could actually see it if we took the zeros off. How many 3's are in 15? 5. How many 3's are in 9? 3. So it's 5 over 3, see? And when we figure it out, because it's time, and we knew it was kilometers per hour, that we're dealing with hours, this simplifies to 1 2/3 hours. So after 1 2/3 hours, the cars are going to be 150 kilometers apart from each other. See? So now we figured out the time. So if the answer makes the equation true, then it's correct. All right? So we could plug this 5/3 in, or this 1 2/3 hours in, and multiply it by 30, and multiply it by 60, add it together, and see if it comes up to 150, which it does. Okay? I'm just running out of room on the board. So our next video, 8.6, is going to be more about systems of equations, and we're going to talk about digit and coin problems. If you want a link to word problems that use substitution or addition method, or if you want to solve for distance or for rate, which was our previous two videos, if you want to learn how to clear fractions from equations, those links are going to be in this description. And I'm also putting a link to Intro Algebra Word Problems, Rearranging Formulas, number 8B and 8C in my Intro Algebra playlist, word problem playlist. Because sometimes you have a formula and you need to rearrange it, and so that you could solve it for the variable that you need. Like this one is being solved for d for distance, but we need to change it to solve it for t. See? So these two videos, 8B and 8C, are going to help you figure out how to rearrange formulas. Okay? All right. We're going to move on and start talking about digit and coin problems. I hope this was helpful, and I'll see you next video. Bye.